Hi everyone, today we are starting 2.3, which is apply deductive reasoning. So yesterday we talked about inductive reasoning. So what's the difference? Inductive reasoning are patterns and examples from conjectures. Deductive reasoning, which we're going to talk about today, uses facts, definitions, and laws of logic to form logical statements. So deductive reasoning, the definition, it uses facts, definitions, properties, and laws of logic to form logical arguments. The first law we're going to talk about is the law of detachment. If the hypothesis of a true conditional statement is true, then the conclusion is also true. So here's our first example. We want to use the law of detachment to make a valid conclusion in the true situation. So for part A, if two segments have the same length, then they are congruent. Think about that statement. If two segments have the same length, then they are congruent. Congruent just means that they are the same length. So we see that that sentence is true. Next, they tell us, you know that BC is equal to XY. So what conclusion can we make? Don't think too much into this. If the segment BC is equal to segment XY, that means they have the same length. So what's the second part of our first sentence? Then they are congruent. So we can then say, well, if they have the same length, BC is congruent to XY. And I'm done there. Let's try this again with part B. Mary goes to the movies every Friday and Saturday night. This has to be a true statement. Today is Friday, so what can we conclude about Mary? Well, we see in the previous sentence, every Friday and Saturday night she goes to the movies. So since today is Friday, Mary's going to go to the movies. So Mary goes to the movies. The next law I'm going to talk about is the law of syllogism, and I'm going to call this law of Syl. So if P, and P is just some situation, so if P, then Q. Remember, Q is just another situation. If Q occurs, then R occurs. Therefore, if P happens, we know that R is going to happen. So let me state that again. So if P, then Q. If Q, then R. Therefore, if P occurs, we know R is also going to occur. This will make more sense once we put it together with an example. So use the law of Syl. If possible, use the law of Syl to write a new conditional statement that follows from the pair of true statements. So here's our statement. If Rick takes chemistry this year, then Jesse will be Rick's lab partner. So I'm going to look at the first part of this statement. If Rick takes chemistry, that's going to be my P statement. Then Jesse will be Rick's lab partner. I'm going to underline that. That is going to be my R statement. If Jesse is Rick's lab partner, well, that's the same as the last part of the first sentence, and we already named that R. Then Rick will get an A in chemistry. We haven't used that sentence yet, so I'm going to use Q. All right, so from the previous slide, we learned that if P, then we know R is going to occur. If R, then we know Q is going to occur. Therefore, and I'm going to put these two dots, those dots mean therefore. If P occurs, we then know that Q is going to occur. All right, well, if we look at our original sentence, if P, then R. If R, then Q. That matches our law of Syl. So my therefore, I can write my P statement if Rick takes chemistry. What can we conclude? Well, then our Q statement, which is then Rick will get an A in chemistry. So then Rick will get an A in chem. And that's it. So let's try this again. If x squared is greater than 25, then x squared is greater than 20. If x is greater than 5, then x squared is greater than 20. So let's label our P, R, and Q. So here's our first sentence here, and I'm going to call this P. Then I'm going to move here, and I'm going to call this R. So we know this should also be R, but wait, those two sentences do not match up. So we have a problem here. So let me erase my work so far. So I can't use law of SIL unless my two R statements match up. So how do you think I could make my R statements match up? Well, the answer is by just flipping these sentences around. So if I were to flip these sentences, so let me rewrite this as if x is greater than 5, then x squared is greater than 25. If x squared is greater than 25, then x squared is greater than 20. So once again, I just took my original sentence and I just flipped them around. Now we'll see we have our R's that match. So this is going to be R, this is going to be R, which means this statement is my P statement, and this statement here is my Q. So remember, law of SIL is if P, then R. If R, then Q. Therefore, if P, then Q. So let's write our therefore. If P, well, if P is if x is greater than 5, then Q, and our Q is x squared is greater than 20. All right, let's move on to part C. If a polygon is regular, then all angles in the interior of the polygon are congruent. If the polygon is regular, then all of its sides are congruent. All right, so once again, our sentences are a little mixed up here. So if the polygon is regular, that would be our P. Then all the angles have to be congruent. That would be our R. But then we see that this sentence here is not our R. But if we also look at this sentence here, that also can't be our R. So this is a trick question that this cannot use the law of SIL. No matter how we rearrange this sentence, we're not going to get our R statements to match anywhere, which means it's inconclusive. It's invalid. Now we're going to look back at the law of detachment and the law of SIL to answer or to come up with valid conclusions for our sentences. So for part 1, if 90 degrees is less than the measure of angle R, which is less than 180 degrees, so R is somewhere between 90 and 80 degrees, then R is obtuse. The measure of R is 155 degrees. Use the law of detachment. What statement can we make? All right, so let's go back to the original. If R is between, the measure of angle R is between 90 and 180 degrees, then R is obtuse. So I'm going to underline that. Well, we know R is 155 degrees. So what conclusion can I make? Well, R is obtuse. We know R is 155 degrees, which is in between 90 and 180 degrees. Therefore, R is obtuse. If Janelle gets a job, then she can afford a car. If Janelle can afford a car, then she will drive to school. Using law of SIL, what statement can we make? All right, let's underline what we know. If Janelle gets a job, so Janelle gets a job, that's going to be our Q. She can afford a car, that's our R. Our next sentence better match up with our sentence R. So if Janelle can afford a car, and look, it does, so that's good, then she will drive to school. That's our Q. All right, so remember, if P, then R. If R, then Q. Therefore, if P, then Q. So I'm going to ignore my R's and just write my if P statement and then Q statement. So if and P is there, so Janelle gets a job. Then my Q statement, which is she will drive to school. State the law of logic that is illustrated. So the two laws of logic is law of detachment or law of SIL. So for part 3, if you get an A or better on your math test, then you can go to the movies. If you can go to the movies, then you can watch your favorite actor. If you got an A or better on your math test, you can watch your favorite actor. Is that the law of detachment or law of SIL? The answer is law of SIL. All right, part 4. If x is greater than 12, then x plus 9 is greater than 20. The value of x is 14. Therefore, x plus 9 is greater than 12. Is that law of detachment or law of SIL? The answer is law of detachment. And here's our last example. Now we're going to think back to inductive and deductive reasoning and telling the difference. So for part 8, each time Monica kicks the ball up in the air, it returns to the ground. So next time Monica kicks the ball up in the air, it will return to the ground. Is this an example of inductive or deductive reasoning? The answer is inductive. And the reason is because we're using a pattern. So use patterns to make conclusions. So she's watching the ball. She knows if she kicks it, it's going to come back down. She does it again, it comes back down. So she's using that pattern to make a conclusion. Part B, all reptiles are cold-blooded. Parrots are not cold-blooded. Sue's pet parrot is not a reptile. Is that an example of inductive or deductive reasoning? The answer is deductive. And the reason is because she's using facts about animals and using her laws of logic to reach a conclusion. So I'm just going to say facts. She's using facts to make her conclusion.